Now we're not going to go much into file input and output, but it is worth knowing that there is such thing as a .npy file. And the way they work is we just create a data set and name it, and then we can use this np.save method, which takes two parameters. It takes the variable name of our array, and it also takes as a first parameter the name that we want our file to have. And so we can save that and load it later using the np.load method, which simply takes the path to our file as an argument. When it comes to linear algebra, we might just simply say that although we don't have to be proficient in the calculations involved with these concepts, we do want to be familiar with the concepts and why they're useful and in what cases they're useful and how they're useful as we go about our business in data manipulation and data analysis. But as I mentioned before, this is not meant to be a math course. So we're just going to use a couple of these functions in ways that potentially we've already used before. So what we're creating here is a 2 by 3 array called the X array, and then a Y array, which is a 3 by 2. And we know by the ways that these are structured that we can multiply them together to get the dot product. Here's a 2 by 3 and here's a 3 by 2. And there's two ways to calculate this. One way is to use X array dot and then use the dot method with the other matrix. And this will yield the dot product from the multiplication of those two matrices. But the other way is to use np dot dot and pass the X and the Y arrays in as two parameters. And if we run that, you'll see that we get the same result. So there's two ways to run the dot product. Now when it comes to inverse matrices and identity matrices and things, we can create this square array down here. Then we can import this inverse from this linear algebra class. And this simple function is going to give us the inverse of our square array. So if we run that and put it in a variable called square inverse, we can prove this is the inverse because it's going to give us the identity matrix when we multiply it with our initial square array. So let's run this, and we see you have your ones on the diagonal, and this is the identity matrix for this array and for this inverse array. Now, in way of conclusion, we mentioned at the beginning of the Python course that we're not asking anyone to memorize all of this, but what we're asking you to do is to get a broad view of what these libraries can do, and then be in a position to do some research to remind yourself whenever you need these tools. Pandas and other higher level libraries are going to be very helpful to us here, and we're not going to have to spend too much time using NumPy. But just as having Python as a foundation underneath NumPy makes a big difference in understanding NumPy, building a conceptual understanding of NumPy and how it works into our foundation knowledge is going to be very helpful for us as we move forward into Pandas and then scikit-learn and finally into TensorFlow.